session on Introduction to Embedded C Programming for the PIC18 microcontrollers. As an initial step, we will see the programming structure for the embedded C programming, followed by the data types, and then a sample programs to interface input and output ports with the PIC18 microcontroller unit. And then on the next video you will see the interfacing programmer using the timers and counters for PIC18 microcontroller units. Let's start with the memory space allocated for the PIC18 microcontrollers. With respect to the program memory, we have 2 megabytes of program memory, which is comparatively low space, but we can do many programs using the program memory. And when we compare with the assembly language code, the C programming takes a less time consuming, and it is very easy to write the program. But the major issue with respect to the hex file. For the C programming, hex file is larger than we compare with the assembly language. Apart from this, by using embedded C program, it is very easy to modify and update. And also you can utilize library functions in the C programming. Moreover, the embedded C programming is portable to the other microcontrollers with little or no modifications required. When we compare with the data types in embedded C programming, we have an character data type with unsigned character. The data range from 0 to 25. If it is a signed character, it's have the data range between -128 to +127. When we compare with the integer data type, we have a 16-bit of integer data type starting from the range of 0 to 65,535. And we have a signed integer having the range between -32,768 to 32,767. Apart from this, we have a signed short int, unsigned short int, and then a long and unsigned long int. So by using these data types, we will see a small embedded C program for the PIC18 458 series to send the data from 0 to FF across the port B. This is a simple program to share the data of 00 to FF across the port B. The program is so simple. So we have a main program. In the main program, the void, it means it has no return data type, and the bracket inside the main representing the no argument or nil argument. Let us declare a data type called character with a name of Z in terms of unsigned. So it has a 0 to 255 range of the character. To initialize the port B as an output, we are using the trace register with the port B. When we assign a 0 to the trace register, it means that the port B is considered as an output port. If we provide the value of 1 across the trace B, it means the port is supposed to be an input port. To iterate over the data of 00 to FF, let me consider a for loop. Whenever you provide a for loop, it should be initialized. We initialize the Z to 0. As we know, for the unsigned character, we represent the Z to 0 to 255. There is an increment parameter called Z++. Inside the for loop, the data start from 0 to 255. It will iterate over the port B. It will keep on when we connect a simulator across this one. The while loop is involved when you run this program in the hardware section. So this is a simple example to illustrate the data flow of 00 to port B.